Hey guys, today we're going to be looking at compound probability. Remember that a compound event includes two or more simple events such as flipping a coin and rolling a number cube all at the same time. Let's just jump in and look at a few practice problems. So what is the probability of a standard number cube being rolled twice and lands on a 2 or a 3 the first time and then a 6 on the second time? So let's highlight the two different events that is happening here because they're rolling it twice, and so we want to know the odds of it landing on a 2 or a 3 the first time and then a 6 on the second time. Okay, since there are two different events happening, we're rolling this dice twice. We're going to set up two different fractions, and for compound probability, we're going to multiply those two odds together. So let's think of a dice first. On a dice, we have the numbers 1, 2, 3, 4, 5, and 6. And the first one's asking that it would land on a 2 or a 3. So those odds would be two numbers out of 6 total. We could also simplify it if we want to make our work a little bit easier. We could divide by 2 and use the fraction 2 divided by 2 is 1, 6 divided by 2 is 3. We could use the fraction 1/3. And then we want to know the odds of landing on a 6 the second time. So same numbers, 1 through 6, but this time we want to land on a 6. And that is 1 out of 6 total numbers. So there's our second fraction. Let's just plug it in over here. So we have 1/3 and 1/6. And we're going to multiply these fractions going straight across. So 1 times 1 is 1. 3 times 6 is 18. And it's a 1 out of 18 chance that we would land on a 2 or a 3 the first time and then a 6 on the second time. Alright, let's try another one. What is the probability of flipping a coin and landing on tails, and at the same time of drawing a card with hearts on it out of a standard deck of 52 cards? So let's highlight the two things that are happening here. I'm going to flip a coin and land on tails. And then draw a card with hearts on it.
Someone's at front door.
So since there's two different things that are happening here, we're going to set up our two fractions and multiply them together. Okay, on a coin, let's think there are two sides that are on a coin, heads or tails, and we want to land on tails. Okay, well that's 1 out of 2 sides, so that will be our fraction for the coin. And then we need to know a little bit about a deck of cards. It's a standard deck from what the word problem tells us. On the standard deck, we have 4 different suits. Of those 4 suits, we have hearts, diamonds, clubs, and spades. Each of these suits have the same amount of cards in them, 13, and we want to know the odds of drawing a card with hearts on it. Well, there's one suit with hearts out of 4, so that fraction of drawing hearts would be 1 out of 4. So let's plug in our two fractions. We have 1/2, we have 1/4, and we're just going to multiply going straight across. 1 times 1 is 1, 2 times 4 is 8, and we cannot simplify this fraction, 1/8. So there's a 1/8 chance that we would land on tails and draw a card with hearts on it out of a standard deck. Alright, let's try another one. What is the odds of purely guessing on 3 multiple choice questions and getting them all correct? So let's think about multiple choice questions for just a minute. On Each multiple choice questions, there's usually 4 answer choices, A, B, C, and D. And there's going to be 3 of those multiple choice questions. A, B, C, D for each. And if we think about taking a test in multiple choice, there's usually only one answer that's going to be correct. I underlined the A, but it could be a C or it could be a D. There's going to be one right answer out of 4 answer choices for each of those questions. So since there's 3 multiple choice questions, there's going to be 3 different fractions. So we're going to set up this time 3 fractions and multiply them together. And the odds of getting them all correct, well, one question will be 1/4, another question will be 1/4, the third question is 1/4, and we want to know the odds that we get them all correct, so we're going to multiply those odds together. So 3 questions means 3 fractions in this case. Well, let's go ahead and multiply. 1 times 1 is 1, and then the answer 1 times 1 is 1 again. 4 times 4 is 16, and then we have to figure out what 16 times 4. Six times 4 is 24. 4, 5, 6. So the odds that you're taking a test and you purely guess, you don't even try to read the problem, you don't try to eliminate any answer choices, the odds that you purely guess and get all 3 questions correct has a 1 out of 64 chance. Alright, let's look at the last one. What is the probability of flipping a coin and landing on heads at the same time as rolling 2 dice and both are landing on a 3? So for the coin, remember there's heads and there's tails. Well, only one of those sides is heads, so that's a 1 out of 2 chance that we would land on heads. Now for the dice, there's 2 dice. So I'm going to list the numbers that are found on a dice twice, and we want to know the odds that both land on a 3. So we have a 3 here and a 3 here. For the first dice, that's a 1 out of 6 chance. And for the second dice, that's also a 1 out of 6 chance. So since there's 3 things happening here, 1 coin and 2 dice, we're going to set up 3 fractions and multiply them together. So for the coin, it's 1 over 2. And then for each of the dice, it's 1 over 6. Let's multiply straight across. So 1 times 1 is 1. 1 times 1 is 1 again. 2 times 6 is 12. And then we need to do 12 times 6. And that is 72. So the odds that all 3 of these things happen is a 1 out of 72 chance. Okay guys, that's compound probability. Depending on how many different events there are, you may need to set up 2 fractions, you might need to set up 3 or even more. And again, it all just depends on how many different events are happening. One thing to always note is when you get your answer, maybe you need to try to simplify. Not many of our questions here had to simplify. Like 1/8 is in simplest form. 1 over 64, that's simplified. 1 over 72, that's simplified. What I mean is, let's say we get the answer 4 over 24. And that answer choice probably is not going to be there if this is a multiple choice question. So if you multiply fractions together, you get this answer. you might need to do what's called simplify. You need to figure out what number goes into both the numerator and the denominator, and I see that 4 could probably go into both. So 4 divided by 4 is 1. 24 divided by 4 is 6. This answer choice would probably be the one that's there. So that's what it means to simplify. Divide, get it into its lowest form. Other than that, just make sure you're multiplying the fractions all the way across. You multiply the numerators together and then the denominators, and then check to see, can you simplify. Thank you guys for watching.